Hey everybody, Morgan here. We are looking at page 13 and 14 of the AP Chem Chemical Reactions lecture, and we're going to be talking about balancing redox equations, and specifically we're dealing with acidic solutions today. And we did do this last spring, but I do have some concerns about how well you retained it, having learned it at a distance. So let's put some real effort into this one again, okay? Now we have what I'm going to call an algorithm for how to do this. And it's got 7 steps the way I have it written up. There are lots of different approaches to how to do this. And I am just choosing the one that in my experience students have always had the best luck using. There are lots of other ways to do it. You're going to get the correct answer with them, but this is the way kids have always told me they found to be easiest. So step number 1 here is find the half reactions. Step number 2 is balance everything. Except hydrogen and oxygen. Okay. Step number 3 is going to be balance oxygen by adding water to the side that needs oxygen. Okay. Step 4, balance hydrogen by adding H plus hydrogen ion to the side that needs hydrogen. Okay. Step 5 is basically equalize charge or balance charge by adding electrons. Step 6 is equalize electrons. Then finally, step 7 is going to be add and cancel. Okay. Pause if necessary to get all that copied down. All right, let's follow these steps and look at our first example here. Find the half reactions. I'm going to take zinc and turn that into zinc 2 plus, and I'm going to take nitrate, NO3 minus, and turn that into ammonium, NH4 plus. Then I'm going to do step 2. I've got 1 zinc and 1 zinc, that's balanced. 1 nitrogen, 1 nitrogen, that's balanced, so no big deal there. Step 3, balance the oxygens. Well, there's no oxygens in the first one, so it's already done. However, in the second half reaction, I've got 3 oxygens on the left, and I don't have any oxygens on the right. So I'm going to add 3 waters. Okay. Now in step number 4, balance the hydrogens. There are no hydrogens in the first one, so that's good. Now in the second one, I've got 4 hydrogens plus 6. 2 times 3 is 6. 4 and 6 is 10. So I'm going to need to put 10 H plus over there. Okay. Now I'm going to equalize charge. That doesn't mean I'm going to make it 0. That just means I'm going to make it equal on both sides. So plus 2 electrons, because a 2 plus and the 2 minus will cancel each other out. Now here I got 10 plus and 1 minus, so that's like a 9 minus. And then I've got a plus 1 on that side. So I'm going to need to add more minuses. I'm going to need 8 more minuses to make them the same. So I'm going to add 8 electrons. If I add 8 electrons, that makes this a plus 1 and that a plus 1, and they're the same. They're not both 0, but they are the same. Okay. Now I need to equalize electrons. I'm going to do that by multiplying this equation by 4, because 2 times 4 will give me 8 electrons. And I'll rewrite that down here. 4 zincs gives me 4 zinc 2 plus and 8 electrons. Now when I add those two together, the only thing that cancels this time is the 8 electrons. So I've got 10 H plus a nitrate plus 4 zincs to give me an ammonium plus 3 waters plus 4 Zn 2 plus. Okay. Now, kind of a quick check, not a perfect check, but a quick check to see if I've done well, is just to look at total charge. 10 plus and 1 minus is 9 plus. 2 times 4 is 8 plus, and 1 more is 9 plus. If the charges on both sides are the same, the chances are it's balanced correctly. I can go back and check every atom, and it's probably a good idea to do that, but if the charge is the same, you probably did a pretty good job. All right, now let's do another one. Let's break this into its half reaction. Cu goes to Cu2 plus, and NO3 minus goes to NO. Okay, now when Cu goes to Cu2 plus, 1 copper, 1 copper. 1 nitrogen, 1 nitrogen. You know what? Step 1 is done. Step 2 is done. Oxygens, there are none in this first reaction. There are 3 here. There's 1 there, so I only need to add 2 waters. Now, for the step where I add the hydrogens, I've got no hydrogens at all in the first equation. In the second equation, none on the left, but I do have some over here on the right. 2 times 2 is 4. That gives me 4 hydrogens. So I'm going to add 4 H plus. Now my charge, plus 2 electrons again. Now this time, I've got 4 positives and a minus. I need 3 more minuses, so I'm going to add 3 electrons. Now, this does not cancel quite as easily. I'm going to need to multiply the equation on the top by 3 and the one on the bottom by 2. So I'm going to get 3 Cu gives me 3 Cu2 plus 6 electrons, and then I'm going to have 6 electrons plus 8 H plus 2 NO3 minus to give me 2 NO plus 2 times 2 is 4 waters. Okay. Only thing that's going to cancel this time also is the electrons, which leaves me with 3 Cu plus 8 H plus 2 nitrates to give me 3 Cu2 plus 2 NO plus 4 H2Os. Now to do a check of the charge, 8 plus and 2 minus is 6 plus, and 2 times 3 plus is 6 plus. So we've got some that are balanced. All right, so at this point, I'd like you to actually attempt to do the next page and then tune back in to the next video to see how you did. All right, this is Morgan signing off.